Good morning. I'm Alex Russell. I'm a software engineer on the Chrome team. And it's amazing to see this event because back in 2011 and 2012, with Dimitri Glaskov and Alex Komorowski, I helped lead a team that did some, I would say, kind of crazy. We spent some crazy time thinking about what the future of the web platform could look like. We did a bunch of prototypes. We ripped apart the tools and libraries that we had. We built a bunch of small applications to see what the problems would be in the web platform if we could use the tip of the tree, if we could actually just fast forward to what everyone would have in 3 years, what was still left as problems. And one of the big things that jumped out to us from this process was that we didn't have a component model. We were missing a way to build custom things that integrated well with HTML. And fast forward to today, web components are a thing, and AMP is the most successful web component library in the world, which is astonishing. So it's incredible to see that there is a diversity of web component libraries in the world, which is something that we had sort of postulated might happen someday in the future, but also that AMP's really interesting restriction on some content has delivered these extraordinary benefits to end users at a moment when it's really critical for users to get a much faster mobile web experience. You heard a couple of talks ago that there are some ads in many geographies where the cost to the user to download the ad outweighs the actual value to the publisher of placing the ad or running the ad and to the advertiser. And that is a terrible thing that I see every day in Traces. So I am an engineer on the Chrome team, and these days I'm working on progressive web apps, working with partners to try to help them get their progressive web apps launched and working on the new technology around it. And so I spend a lot of my day looking at mobile websites. I'm looking at websites from emerging markets on 3G networks. And I can tell you that AMP is an incredible leveler for the problems that we're up against. So 2011, we start working on web components, ES6, a bunch of new features in the web platform. And then time happens. And then in 2013, 2014, we start looking at what's still missing from the web. And so what was missing from the web was an application model. Let's say we have a component model, right? It's 3 to 4 years later. Great, we have a component model. Life is good, right? We've solved all of the problems that the web ever had, except that mobile came and ate our lunch. We had one on the desktop. We had actually built a world where we could spend most of our time doing email in a browser. We could do most of our documents in a browser. We didn't actually have to leave the browser to do very much. Except on mobile, we never really quite got there. Today, we're seeing that users spend between 12 and 13% of their time on a mobile device inside of a browser of one form or another. There's a little bit of dark matter there. We don't kind of know what time is being spent in the sorts of in-app browsers that you may see commonly, but we know that it's not growing dramatically. We know that the time that users are spending on the web, on the mobile devices, is not growing dramatically. And that's sort of a problem, whereas on desktop we had seen a huge growth, and it's definitely more than 13%. Today we're sort of static. Like, so what's missing, right? Why is it that the web is still a difficult thing to get back to for users? And so we talked to a lot of developers. We looked at the evidence of what people were doing. We, again, built some prototypes. And we realized that, of course, we're missing a home screen presence, right? If you can't be part of that tap and swipe ecosystem for the user, it's very difficult for users to re-engage with your experience. And when we talk to publishers and we talk to partners, they frequently cite that as a reason for building a native app. They want to be on the home screen. Now, users, of course, aren't going to put every app on the home screen. We know that users have a fatigue around this. But what that means is that there's a bit of a mismatch, right? Publishers are having to spend a lot of money to go build a separate experience, to go get their brand on the home screen for a subset of users who are extraordinarily engaged. But that's not all of their users. And in fact, in many cases, it's not even a large proportion of their users. It's often a vanishingly small but extraordinarily profitable subset. So that's interesting. And those users really do want to have the best experience of that brand. They want to be able to come back to their habit, their daily thing. They want to be able to get back to it easily. They don't want to have to go through the indirection of opening a browser, tapping something in, waiting for the autocomplete. Maybe the network isn't working, right? That's terrible. And speaking of the network, they also really want reliable performance. One of the big differentiators that I don't think that we spend enough time talking about on the web between what native apps can deliver and what the web has so far not delivered has been that when I tap on an application on my home screen, I always get something. it always loads something. I don't get the offline thesaurus. That never happens to me in a native application. There's no platform-wide expectation that things will fail just because I happen to be on a different network type. That doesn't happen with native apps. So we need a way to give the web reliable performance, reliable communication with the user about what's going on from the application. We can't continue to have a situation where everyone expects that things will be slightly slow or that they might be broken some other time. And then lastly, of course, the brand new surface area that we didn't see coming is the notification tray. And it's part of that tap and swipe ecosystem. And the web has been absent from it. So we needed to fix it. So we added a bunch of this stuff. And today it's all sort of wrapped up inside of that notion of a progressive web app. So it isn't one technology. It's not like AMP. It's not like a thing where we've got a validator for it. Although there is a new tool called Lighthouse that you should totally use if you're building a progressive web app, because it will help you validate that you have met the criteria that we would like for you to hit. But all of these things are available a la carte. So you can build, like CNET did, a progressive web app that will load offline, and it can get that add to home screen prompt from the browser if the user engages with it a couple of times, or for a couple of minutes, actually, these days. It can be on the home screen. They can tap it, go to this full screen experience, and then eventually just continue to tap and swipe through this card-based UI. As you can see, on the left, we've got the same experience loading inside of a tab in the browser, and then once it relaunches from the home screen, it acts like an app. It's a standalone activity in the task switcher. Users would be forgiven for thinking of it as an application. Service workers provide a fast, reliable experience that makes it possible for the developer of this application to deliver that experience fluidly every time at every moment. Flipkart.com, the largest retailer in India, has built an extraordinary progressive web app, which, for my money, is indistinguishable from their native application, and I recommend you check it out. Push notifications are also one of these big deal things, and you can do it a la carte. So for instance, weather.com today isn't a progressive web app. You can't install it to your home screen. It actually doesn't work that way. But you can add push notifications. The same thing is true of Facebook.com. Today, Facebook.com on desktop and mobile will offer to give you push notifications using an open standardized protocol that we spent several years developing with our friends and partners at Mozilla and Microsoft and other folks, and is now available widely in browsers. And so that means that even if the developer hasn't decided to make their experience app-like, it can still re-engage users when there is something important for them to come back to. And that's available to you, again, a la carte. These things all add up to an app-like experience, but you can have them piecemeal. You don't have to add the manifest file that gives you that metadata for the icon. You can just have a service worker. You don't have to do push notifications to have a progressive web app. You don't have to have offline capability to do push notifications. But when you get them all, when they all add up, it does feel like you've been transported to a new world. And this all, I think, is worth thinking about in terms of keeping those engaged users who are already on your site, who have already come to your experience, keeping them more engaged over time. So does it work? Well, we're still looking as hard as we can to try to understand whether or not it does work. But what we're seeing from a bunch of partners is that the acquisition cost for an engaged user on a progressive web app is radically lower. Now, most folks that we talk to aren't willing or able to share this sort of data with us, but the Housing.com team built an exemplary progressive web app, which is something that you should try out on your Android phone. And it dropped their engaged user acquisition costs by 50x. Now, this is a bit of an outlier. It's a little bit higher than some, but we've seen others like Celia, which is a startup in Europe working on a local marketplace, drop their user acquisition costs by 10x. So this is not unique necessarily. It is just very large. But the numbers are eye-popping even if it's only 10x. Right? Getting a user today in a native application, we've seen over and over and over again, is extraordinarily expensive. Between native app installation ads, between the sorts of in-house marketing that you have to do to convince users on your website to go through the application installation flow, the amount of friction that's involved there causes the distribution of your native applications to be a very expensive proposition. And so when we talk to many publishers, it is interesting to hear how they are attacking that problem. And the value of progressive web apps is that you can simply turn the application that the user is already on into the application that they can re-engage with. And you can do that without a big upfront install, right? So this is working pretty well in the marketplace. Flipkart saw 70% higher conversions for the users that did do the add to home screen flow. Jumia has 9 times more conversions versus previously abandoned carts. AliExpress, one of the largest retailers in the world, saw a 74% increase in time spent across all browsers, not just the browsers that support progressive web app features natively. For instance, Safari doesn't support most of this. But investing in your mobile web experience, your owned and operated website, and adding the sorts of focus on reliable performance that you need to get to progressive web apps does pay off everywhere. So this is great, and this is amazing for your website. But it seems like there's a bit of an impedance mismatch. If AMP is about creating this extraordinary experience for users when they come through the side door, when they come through the federated versions of your content, and progressive web apps are about creating an extraordinary app-like experience for the users who happen to be on your website directly, it seems like having instant delivery and optimized discovery are in direct competition with having advanced platform features and having dynamic content. So can we solve this? Can we bring these two things together, right? Because what we want is for users to have that extraordinary fast experience of an AMP document wherever they first discover your brand, and then when they come to your site, continue that journey but have the upgraded version, right? AMP is constrained. AMP has natural constraints, and there are constraints about how AMP is distributed that mean that we'll never be able to do things like push notifications directly from AMP documents. We will not be able to ask, per se, for that because it's served from a different origin most of the time. You can, of course, serve AMP content from your origin, but most users will experience your AMP content through a viewer, for instance, the Google viewer in search that we heard about in the last talk. So given that that's the case, given that that's from a different origin and we can't, for instance, provide those permissions to those users in that instance, is it possible then to just keep the performance where we hand off from the user who is engaged with our content and the AMP viewer, and then when they transition to being on their website, can we get to starting fast and staying fast? And yes, of course, there's value in doing that because we all know that faster is better. This is data from SOASTA from last year, and what they show, of course, is that bounce rates really, 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 really matter. DoubleClick did a study last year. They saw that users have much higher bounce rates if they don't get to the content in 3 seconds, and that most seconds on mobile take 19 seconds to load. So we have a long, 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 long way to go. AMP is an extraordinary way for us to help the front part of that conversation with the user who's coming through the side door. But then how do we fix this for our sites? What do we do about our pages? So there's a couple of complementary approaches that I think we can investigate. We have sort of played around with a couple of things, and I think Paul asked me to give this talk because no good deed goes unpunished, and in 2015, I prototyped a way for AMP and progressive web apps to sort of work together. But that's not the only way that they can work. There's 2 approaches, sort of called AMP up and AMP down. AMP up is the background bootstrapping of a progressive web app shell while the user is on the AMP page. We've seen a couple of examples of that already, and I want to show you a few more today. And AMP down describes reusing AMP content inside of a progressive web app. So these 2 things are possible. We sort of thought that they might work, but we're starting to seeing them working together. So let's talk about AMP down first, embedding AMP as the source format for our content inside of a progressive web app. So the way this roughly works is that you build something like a shell, a host for your AMP content. Now, there are several ways to do this. You can do this using an iframe. You can use the shadow DOM. That's part of the web component specification to do this. But your content inside of this shell, which is built in whatever technology you want, that's running on your website. So for instance, Mike.com is using React. This content is running inside of a shell that provides a very fluid in-site navigation, right? You don't have to think about transitioning between pages because it's all AJAX-STAN, right? You have a stable UI, nothing goes away. You can provide things like push notifications, which is that toggle on the upper right, and you can get to this today at beta.mike.com. This is a great way to deliver an experience which reuses the work that you've already invested in AMP. Because once you've got AMP and a PWA, you have this tension about, like, is AMP just a sort of a side format? Is it just an RSS for my PWA? Or is this actually the source format for all of my content? And what we see with the AMP down pattern is that this can be the source format for all of your content, resolving a bunch of the ambiguity and the tension that you may have felt about what you should do, right? You get the benefits of that fast content, but you keep the responsiveness and capabilities based on the progressive web app. So CNN Español has been building an experience exactly like this. This is what you get to when you go to their new site, which is not yet launched, but you'll see it soon. And I'm grateful to be able to show it off today. It implements push notifications. It works on the home screen. It's a light, fluid, fast experience. And when you go there, you can see both articles and videos in a nice swipeable package. It's really, really, really well done. And when you tap into an article, like that first one there, what you get is an AMP document. That is a shell that has been built, an app shell, which can always load. That app shell is something that the progressive web app will, even when the network is flaky or you're offline, will boot up with no matter what, recreating that experience that we sort of covet from native applications, where whenever I tap on the home screen icon, I always get something. And that's the experience that progressive web apps can deliver, and CNN Español has done it by hosting the AMP content in an iframe. Very much like the AMP viewer that you heard about in the last talk, CNN Español has built basically their website as an AMP viewer. So this is a pretty good pattern. And what it does is it removes the distinction between the URL, perhaps, between the AMP content and the owned and operated content. You don't have to fight about what is your source format. It's just the AMP format. So AMP, as a way of keeping your own pages fast and lightweight, using the validator to ensure that that's possible, is a really nice way and a really good pattern for making this all happen well. So there's a variation of this, which we sort of call shell rewriting, and Paul Backus has put a lot of time into this, and this is sort of the AMP down stable URL option. And the way to think about this is that the progressive web app loads, and then it hijacks the navigations. So you start clicking on an article, and instead of reloading the entire page like you normally would, it fetches that content in, very much like the CNN Español page does. It puts the content inside of a web component shadow root, which is like an iframe, except it's not actually isolated as a separate document. And you can call the attach shadow doc method on the AMP instance to ensure that your content is actually shown. So now we've got a conflict, because the content might have its own navigation. You might have an AMP menu. You might have a bunch of other CSS that would be fighting for control over that top-level branding and navigation UI. But there's a clever hack here that you can do that Paul sort of put together, where you can use conditional CSS on the shadowed AMP document to automatically hide stuff like headers and the embedded content that you don't want to display in this other mode. So the shadow slots allow you to also add a bunch of interactivity that you might not in a regular AMP document, right? One of the big advantages of progressive web apps is that you can do anything. You can actually extend what you thought the platform could do much further, and that means doing things like VR and audio, web audio, and really immersive experiences, Bluetooth. Like, you can make anything on the web these days. And what that means is that in order to be able to access that, you really want to be able to do it on your origin. But maybe the same document degrades gracefully when it's being served someplace else. And so using this sort of slot technique where you wind up rewriting the content a little bit in order to make sure that when it's hosted, you can load these richer elements that you provide dynamically, but only when they're on your own site. You can use the shadow DOM to ensure that you have a great place to put this more dynamic content when it's hosted on your origin versus when it's being hosted on the AMP CDN. All right, so how does this work? Well, this is the only code I'll show. Basically, you have a fetch event handler, and if you decide that it's happening from your AMP shell, then on your own origin, and you're navigating to it, you can actually send back initially the content of that shell, the progressive web app. You can send that back all the time, every time, and then start downloading in that initial fetch exactly what you wanted to get from the network. So you can load the shell immediately every single time that you navigate to a URL that might otherwise be an AMP page once the service worker is installed. The important part about this pattern is that it means that you don't have to have two sets of URLs. You don't have to build a /amp or an amp dot. You can just host everything at the same URL. Users who don't have support for progressive web technology like service workers will just get the amp document, which for most users, most of the time, is a great experience. That's actually where we want to be. We want to give users a fast experience when they can get it. Now, the users who do have this can get that upgraded thing. They can get the version of it that adds new technology that we've just made available in browsers. All right, let's talk about the other pattern. AMP warming up the progressive web app. So the Washington Post demoed this last summer. There's a new AMP element called AMP install service worker that you might not be familiar with. But the basic idea in this pattern is that when the AMP document is viewed through the AMP viewer on a different origin, not your origin, the AMP install service worker element makes a dynamic decision about whether or not the document is actually from where you thought it was, whether or not the user is engaged enough to go do this extra work. But if they decide that it is, it points at a bootstrap file that is on your origin. So for instance, example.com/pwa.html, and that bootstrap file just installs a service worker. This element, when it's loaded on your origin, also points at the service worker file directly and installs it in the other case. So it gives you a chance when the user is reading the article on for instance, the Google AMP viewer, to start getting your app installed, so that when they tap on the next link, you actually get an instant handoff. You never have to hit the network, because once the service worker is installed, it can handle that navigation. You can get that starting fast experience of the AMP viewer, wherever that happens to be, ending you up at an extraordinarily responsive next load. So who's doing this? Well, the Washington Post did an experiment, and they turned it off, so they're not doing that anymore. But interestingly, and I'm happy to talk about this, Forbes is doing this now. So if you Google for something, for instance, Forbes investment advice, and you click on any of the AMP colored links later in the page, and you'll get this in the AMP viewer, today's AMP viewer, which is pretty great. It's a fast experience. And if you scroll down far enough in the page, the AMP install service worker element will do roughly what you expected it to do. And when you tap on one of these links, for instance, the trending on Forbes links, this will take you to their new progressive web app. And that new progressive web app is a great tappable, swipeable, card-based experience. But it installs extraordinarily quickly in the background. And if you engage with it enough, what you'll get is the add to home screen. So now we've gone from a fast experience hosted by the AMP viewer to a navigation out to your own site without potentially ever hitting the network. It can be extraordinarily quick. It can stay instant the whole time. And then when the user engages enough, it can transition into being an application for the user. In fact, it can live on the home screen along with all of your other progressive web apps. And when you launch it, you'll get a custom splash screen, just like all of your other applications. And now it's running full screen. So this is an experience that has been upgraded out of the tab and into the app world. So now we're part of the touch and swipe ecosystem without losing the user at any step in that flow. So does it work? Well, we heard yesterday from Wego, and Honey's talk was amazing, that Wego their progressive web app is doing exactly this sort of handoff, and the data that they showed was amazing. A couple of seconds to load the progressive web app for a new user, but if the user gets to that content from the AMP cache, it loads in less than a second to start with, and if they do the handoff and they've installed the service worker, you're, again, less than a second. You stay under that 1 second threshold, which has, to date, on the web, been almost impossible to do. The RTT time of 3G networks make it almost impossible for us to do anything in under a second if we're waiting on the network, right? That flash of white, that dreaded flash of white where you tap on a link and you're just sitting there waiting, that goes away when you implement a pattern like this, because the user has gone to Google, and Google has started to pre-cache all that AMP content from your origin, and then you've started to pre-cache the PWA content for your origin from the AMP content. And so, you know, the data that Wego is showing us is incredible. Organic visits up 12%, searches up 26%, conversions up 39%, and visits to conversions up even more. So this is a pattern that you can deploy today. It works. It's not black magic. The AMP install service worker element works well. If you're implementing a progressive web app, it's easy to do if you also happen to have AMP content. And if you're building from scratch, thinking about AMP as a source format, as a way for you to reuse the effort that you've put into building great AMP content to host it inside of your progressive web app is also just as possible. People are succeeding with it, and you can do it today. Anyway, thank you so much, and I'll be around if you've got questions later.